Hello dear students, today we are going to discuss about angle of repose. In the previous section, we people have discussed about angle of friction. Angle of friction is the angle between the normal and the resultant force between the normal and the frictional force. Between the normal and the maximum frictional force, I can mark it as maximum. This is the angle theta. This angle theta is called angle of friction. So, angle of friction is the angle between the normal and the resultant between the normal and the maximum frictional force. And you got an expression for it as tan theta equals mu s. So the coefficient of static friction is numerically equal to the tangent of the angle of friction. The coefficient of the static friction is numerically equal to the tangent of angle of friction. This expression is required because we are going to discuss about angle of repose. We have to compare what is angle of repose and angle of friction, and then we have to arrive at a conclusion then that what makes the difference between this angle of repose and angle of friction. Let us get into the angle of repose. You consider a inclined plane which is making an angle theta with the horizontal. Let us say a body of mass m which is placed on the inclined plane. A normal reactive force N acts perpendicular to the inclined plane, and as you know very well, mg, a gravitational force, will be acting vertically downwards. This mg can be resolved into two components. One is mg cos theta, because if this angle is theta, this angle is also theta. I can say this as mg cos theta, and then this can be taken as mg sin theta. Then the maximum static frictional force will be acting in a direction opposite to mg sin theta, so I can mark it as Fs maximum. In order to explain the diagram, I am telling all this. Now, let us consider an inclined plane which is making an angle theta with the horizontal. This is the horizontal. This is the inclined. If the angle made by the incline with the horizontal is very small, then the object placed over the incline or the block placed over the incline will not move. As you increase the value of theta gradually, for one particular value of theta, the block placed over the incline begins to slide down the incline. The angle theta at which the object placed over the incline begin to slide is called angle of repose. So the term is very clear. Repose here refers to the extent to which the object manages himself or itself over the inclined surface without getting slided over the surface. So repose here refers to the extent, the opposition provided by the inclined surface over the block or a body placed over the inclined surface in order not to move or slide down the surface. So what we are discussing is that on the incline, the angle between the incline and the horizontal is very small, then the object will not slide down. As the value of theta increases, then at one particular value of theta, the object begins to slide down. It will move down in the downward direction. So the angle at which the object begins to slide down the incline is called angle of repose. So we can say the angle made by the incline with the horizontal such that the object placed over the incline begins to slide is called angle of repose. So angle of repose is the angle made by the incline with the horizontal such that, see this one, such that the block or mass placed over the incline begins to slide down the incline. Let us see the kind of forces, the different types of forces acting on the block placed over the incline. I can draw a FBD here, a normal force acting, actually this is the incline. So with respect to the incline, a normal force acts perpendicular to it. mg, a gravitational force acts vertically downwards. I can resolve this into two components. This is theta. This one is mg cos theta, a perpendicular component to the incline. So while drawing FBD, you should not draw this kind of reference lines. You have to consider the body alone. But to explain which one is the parallel component and which one is the perpendicular component, I am just taking a reference line here. This is mg cos theta and this one is mg sin theta. This one is the parallel component which is parallel to the incline, and mg cos theta is the perpendicular component which is perpendicular to the incline. So there are two components, mg cos theta and mg sin theta. mg sin theta is the parallel component to the incline and mg cos theta is the perpendicular component to the incline. And as I told you earlier, this is Fs maximum, the maximum static frictional force acting on the body of mass. Yeah. What is the role of this parallel and the perpendicular components? We can say here, this mg sin theta makes the body to slide down the incline. The parallel component of this gravitational force makes the body to slide down the incline. And the perpendicular component of this inclined inclined surface, mg cos theta, balances the normal force or reactive force. So the parallel component mg sin theta slides down the incline. The perpendicular component mg cos theta balances the normal force. It balances the normal force. As we saw, as the value of theta is gradually increased at one particular value of angle theta, we said here that the object begins to slide down. The point at which the object begins to slide down is called the angle of repose. We saw that. Based on that, we are saying that mg sin theta is the component of mg which makes the object to slide down the incline. And mg cos theta balances the mass and it also balances the normal reactive force. When the object begins to slide, see the statement, when the object begins to slide, you might have seen in the graph, between the external force applied over the body of mass m and the frictional force F. As the external force increases, the frictional force also increases. For one particular value of external force, the frictional force will attain its maximum value, Fs maximum. This is the maximum value of frictional force. If the external force applied to the object placed over the surface exceeds this Fs maximum value, then the object begins to slide over and it starts moving with some amount of kinetic energy. So the static friction gets transformed to kinetic friction here. So this is the kind of graph which you have seen in the earlier classes. So what I can say is, this is the point, this is the critical point where the transformation is taking place. The static friction gets transformed to kinetic friction. This is the point where the static friction gets transformed to kinetic friction. So simply we can say here, when the object begins to slide down, so at the time of the beginning of sliding of the object over the inclined plane, the static friction will attain its maximum value. That is the point where the kinetic friction starts. That is why the graph has been given like this. This is the line. This is the point where static friction whose maximum value is there, kinetic friction whose starting value is also there. So this is the external force for which the static friction gets transformed to kinetic friction. The maximum value of static friction gets transformed to kinetic friction. So what you can understand from the graph is that when the object begins to slide, say this one, begins to slide, then we can simply say here the static friction Fs will attain its maximum value, Fs maximum. That is the value of the maximum frictional force where the kinetic friction begins to the object when it starts sliding over the surface. So I can say here Fs, the static frictional force, is equal to Fs maximum. Fs maximum is known, this is mu Sn. Actually, you might have seen this expression or seen this condition here, 0 less than or equal to Fs less than or equal to mu Sn. Even you can take it as Fs maximum is equal to mu Sn. Minimum value is 0. So, Fs, the value of static friction lies between 0 and mu Sn. Lies between 0 and mu Sn. The maximum value of static friction is mu Sn. So, when the object begins to slide down the inclined surface, the static friction is equal to Fs maximum, that is equal to mu Sn. And what is this value of normal force? That we can obtain from this diagram. The normal force is balanced by the mg cos theta component, which is the perpendicular component for the inclined surface. So I can say here mg cos theta balances the normal force. So n is equal to mg cos theta. I can consider this as equation number 1. This one as equation number 2. Substitute 2 in 1. You will have Fs maximum is equal to mu s into mg cos theta. I can consider this as equation number 3. Equation number 3. Fs maximum is equal to mu s mg cos theta. Mg cos theta. Also, from the diagram, when you compare the horizontal components, I can take this as x component and y component. When you take these horizontal components or parallel component to the inclined surface, you can see here mg sin theta is equal to Fs maximum. So also you can write Fs maximum as mg sin theta. This is equation number 4. So for Fs maximum we have two expressions. One is mu s mg cos theta. Another one is mg sin theta. Then left hand sides are equal. So that you can equate the right hand sides. What will you get? You can have mg mu s mg cos theta, mu s mg cos theta is equal to mg sin theta. I'm just equating. If Fs maximum is on the left hand side, then right hand sides will be equal. If these two are equal, then these two must be equal. Can cancel out this mg and mg. Mu s is equal to sin theta divided by cos theta. So I can write mu s is equal to tan theta. Mu s is equal to tan theta. For angle of friction also, we saw the coefficient of static friction is equal to tangent of the angle of friction. So this is the expression obtained for angle of repose. Also you had the expression for angle of friction as mu s equals tan theta. What is the difference between these two? Both are equal. So angle of friction and angle of repose are the same. Angle of friction and angle of repose are the same. Then what makes the difference here? Angle of repose is meant for inclined surfaces and angle of friction is meant for any kind of surface. Angle of repose is meant for inclined surface. Angle of friction is meant for any surface. That makes the difference. We can apply this angle of friction or we can calculate this angle of friction to any surface. When you are speaking about inclined surface, there angle of repose comes into play. Here theta is the angle of repose. Here theta is the angle of friction. That makes the difference here. So mu s equals tan theta. Once again, what is the angle of repose here? Angle of repose is the angle made by the incline with the horizontal such that the object placed over the incline begins to slide down. So what is that angle? This theta. So tan of theta is equal to mu s. So I can say here tan of the angle of repose is equal to the coefficient of static friction. What is the unit of static friction? No unit. Because tan of theta is mere number. So mu s is also a number. So this coefficient of static friction is a mere number. It has no unit and it differs for different types of objects placed over the inclined surfaces. If the surface is the same, If the object placed over the surface differs, then the coefficient of static friction also differs. So mu s is equal to tan theta. We call it angle of repose. The same expression is there for angle of friction also. But the angle of repose is meant for inclined surfaces and the angle of friction is meant for any kind of surface. Now we shall speak about, or we shall discuss about the problem related to the angle of repose. So we are discussing about the angle of repose here. Theta is the angle of repose, which is the angle made by the incline with the horizontal, such that when object placed over the incline begins to slide. What is the angle of inclination for which the object placed over the incline begins to slide? That is called angle of repose. We are discussing about the different kinds of forces acting on the mass placed over the incline. Normal force, which is exerted by the surface, we used to call it reactive force. Mg is the gravitational force, which is resolved into two components. One is mg cos theta and another one is mg sin theta. Mg sin theta is considered as the parallel component to the incline. Mg cos theta is considered to be the perpendicular component to the incline. Fs maximum is the maximum static frictional force acting on the object placed over the incline. So, what is the role of mg sin theta? It slides down the incline, slides down the object placed over the incline. What is mg cos theta? What is the role of mg cos theta? The vertical component balances the normal reactive force. Our normal reactive force balances mg cos theta. And we can say here, when the object begins to slide down, the static frictional force is equivalent to its maximum value, Fs maximum. And you know Fs maximum is mu s n. So this is one way where the normal reactive force can be calculated from the diagram. When you compare the vertical components, we can write mg cos theta is equal to n. So n is mg cos theta. Fs maximum is equal to mu s mg cos theta. This is one equation. Also from the diagram, when comparing the parallel components to the inclined surface, we can write Fs maximum is equal to mg sin theta. Then, if the left hand sides are equal to the right hand sides, you will have mu s mg cos theta equals mg sin theta. Mu is sin theta by cos theta, which is nothing but tan theta. We used to call this as angle of repose. The same expression has been obtained for angle of friction also. Angle of repose is meant for inclined surfaces and angle of friction is meant for any kind of surface. So I can state that the tangent of the coefficient of static friction is equivalent to the tangent of angle of friction, or the coefficient of static friction is equivalent to the tangent of angle of repose. Whatever the statement is, both are same. But thing is that you can use this mu is equals tan theta, where theta is the angle of repose. This is used only when you discuss about the sliding of object over the inclined surface. This expression must be used when you speak about the movement of object over the horizontal surface. So based on this angle of repose, we shall discuss a problem now. Example 3.20. A block of mass m slides down the plane inclined at an angle of 60 degree with an acceleration g by 2. Find coefficient of kinetic friction. They are asking you to calculate the coefficient of kinetic friction. So the angle of inclination is 60 degree. Angle made by the incline with the horizontal is 60 degree. Acceleration is g by 2. So if you draw the diagram for this question, I can write theta equals 60 degree. The coefficient of kinetic friction comes into play when the object begins to slide down. Fs maximum can be taken as Fk. Fk. So the coefficient of kinetic friction or the kinetic friction comes into play when the object begins to slide down. I can say the different kinds of forces acting on the mass are the normal force N or the reactive force, mg which acts vertically downwards. This is mg cos theta where theta is 60 degree, and this one is the parallel component mg sin theta. So mg cos theta is one component, mg sin theta is the parallel component. As we saw, mg cos theta balances the normal force, mg sin theta component is equivalent to Fk. They have mentioned that the mass is sliding down with an acceleration A is equal to g by 2. This is important. It means the block is not at rest, it is sliding down. So the net force acting on the mass m makes the object to slide down. We need the inertial coordinate system. to explain the movement of the object with a free body diagram, we can say here the components along the horizontal direction are mg sin the forces acting along the horizontal direction, or otherwise what we call the parallel direction to incline is mg sin theta and fk. Mg sin theta is acting in one direction, fk is acting in the opposite direction. So I can write here mg sin theta minus fk is equal to ma. Why am I writing mg sin theta minus of fk? As I told you earlier, mg sin theta is the force or the component of mg which makes the object to slide down the incline. This is pulling the object in the downward direction by overcoming the frictional force. So I can write here mg sin theta minus of fk is equal to ma. This is the expression. Actually, you have studied all these ideas in FBD, free body diagram. If you draw xy coordinate, inertial coordinate system, you can compare the components here. You have to speak out all the forces acting on the body. All the forces acting on the body must be taken on the left hand side of the equation, and then that must be equated to the product of mass into acceleration. We are applying Newton's second law. Your net force is mg sin theta minus of fk, and this is equivalent to ma, mass into acceleration. And they have mentioned the acceleration is g by 2, so I can write mg divided by 2. So mg sin theta minus of fk is equal to mg divided by 2. Instead of ma, I am taking it as mg divided by 2 because they have mentioned acceleration a is equal to g by 2. What is the value of theta here? 60 degree. So I can write mg sin 60 minus of fk is equal to mg divided by 2. What is sin 60? Root 3 divided by 2. So root 3 by 2 mg minus of fk is equal to mg by 2. Fk is equal to root 3 by 2 minus of 1 by 2 into mg, or else I can write fk is equal to root 3 minus of 1 divided by 2 into mg. This is fk. But what is asked here? You are asked to find out the coefficient of kinetic friction. So acceleration is taking place along the horizontal direction, in the sense in the parallel direction to the incline. The vertical components have no role in accelerating the body. So simply I can write mg cos theta is equal to n. Simply n. mg cos theta is equal to n. mg cos theta is equivalent to the normal reactive force. What is cos of theta, or what is theta? 60 degree. So mg into cos 60 is equal to n. Cos 60 is 1 by 2. So mg by 2 is equal to n. mg by 2 is equal to n. Then you are asked to calculate the coefficient of kinetic friction. What is coefficient of kinetic friction here? What is coefficient of kinetic friction here? You can write Fk is equal to mu k into n. Fk equals mu k into n. As we used to write F is equals mu s into n, maximum value of static friction gets transformed to kinetic friction. Fk is equal to mu k into n. There is no such confusion here. The point where the object begins to slide is the point where the object experiences its maximum static friction. That is the same point where the object begins its kinetic motion, so kinetic friction. So Fk is equal to mu k into n. We need to calculate mu k. Mu k is equal to Fk divided by n. What is Fk here? Root 3 minus 1 by 2 into mg. So Fk is root 3 minus 1 divided by 2 into mg. What is n? Normal reactive force. We have calculated it as mg divided by 2. So this mg cancels out, 2 gets cancels out, you will get to root 3 minus 1. Root 3 is 1.732 minus of 1, 0.732 mu k. Mu k equals 0.732. The value of coefficient of kinetic friction is 0.732. There is no unit at all, it's mere number. From this value of coefficient of kinetic friction, we can also calculate the angle of repose. Because mu k equals tan theta. If mu k is 0.732, then you can calculate the value of theta here. You can use a calculator to get the value of the angle of. So by knowing the value of mu k, we can also calculate the angle of repose here. Mu k is 0.732. This is tan of theta. Theta equals tan inverse of 0.732, which is approximately 36 degree. This theta is the angle of repose. So theta is approximately 36 degree. This is the angle at which the object placed over the incline started sliding down the incline. Applications of angle of repose. You might have seen insects which will create this kind of traps. This is a kind of trap, sand trap, over the surface of the sand. Actually, this is made by an insect called antlions. You might have seen, those people who are there in villages might have seen this kind of sand traps. A cone-shaped sand trap will be there. Actually, this kind of sand traps are generated by antlions. They hide themselves at this particular point where the apex of the cone is there. When insects approaches this edge of the sand trap, they begin to slide down the incline and they reach the bottom of the incline where the antlions hide themselves to catch the insects. This is a natural way of hunting the insects by the antlions. What is the special thing about this? Thing is simple. The angle made by the this incline with the horizontal is equal to the angle of repose. That is the reason why when the insect approaches the edges of the sand trap, they started sliding down the incline. Actually, we saw when an object placed over the inclined surface, then the object begins to slide when the incline makes certain angle theta with the horizontal. So if this is the horizontal, we can say here if it makes some angle theta with the horizontal, this is the angle of incline. This is the angle of incline, or angle made by the incline with the horizontal. Then this angle theta is called angle of repose. So this angle is made by these antlions so that when an insect approaches this point, the edge of the sand trap, they begin to slide down the incline. So they can catch the insects easily, so they can have their prey. This is one application which is related to angle of repose. Another application is that the sliding boards. Children are very much interested. They are fond of sliding over the sliding board. The sliding boards are made in such a way, or they are placed in such a way that when the child climbs up the stairs and when they start reaching this edge, they begin to slide over. And this is quite simple. The angle theta made here is slightly greater than, you can simply say here theta is slightly greater than the angle of repose. The sliding board whose inclination must be slightly greater than the angle of repose, so that the children who are sitting over here are sliding down the incline and they reach the bottom, provided the angle theta must be slightly greater than the angle of repose. If the angle theta is much greater than the angle of repose, what will happen? If it is much greater than angle of repose, much larger than angle of repose, then they will move with greater speed. They will move with greater speed. They will slide with greater speed and will reach the bottom with greater speed, and they will hit with the ground, and so that they will get hurt. So this should not happen. This should not happen. If this thing should not happen, then we must be very cautious enough that the angle theta must be slightly greater than the angle of repose, so that they can easily slide over the sliding surface. This is another example for angle of repose. There are different ways by which we can find out the angle of repose, and also we can calculate angle of friction. And at the same time, we can also calculate the coefficient of static friction and coefficient of kinetic friction. Activity is given in your textbook. It is very simple. You just take a hard cover of a notebook. Let us say you lift up the cover of the notebook, which makes an angle theta with the paper surface. You place a coin over the surface. slightly increase the value of angle theta. What will happen? At one particular angle theta, the coin begins to slide down the hard cardboard of the notebook. So the angle theta at which the coin begins to slide down is called the angle of repose. So you can calculate or you can measure the angle theta between the hard surface of the notebook and the horizontal surface of the paper, so that you will get the value of angle of theta, from which we can calculate μs, the coefficient of static friction. Also, you can calculate the coefficient of static friction for different objects. Instead of placing a coin, you can place an eraser or you can place any other object. The angle of repose differs, and the coefficient of static friction can be calculated for different objects which are placed over the inclined surfaces. Then, second thing, you can calculate the coefficient of kinetic friction also. How come you can calculate the coefficient of kinetic friction? When you increase the value of angle of theta, for one particular value of theta, the object begins to slide down. Now you lower the inclined surface, you decrease the inclined surface. What will happen? The object which started sliding down the inclined surface will begin to move with the constant uniform velocity, or it will move with the constant uniform speed. So when the object begins to move with the uniform speed, then you calculate the angle theta over there, which will give you the coefficient of, or theta will give you, from which you can calculate the coefficient of kinetic friction. Find out the value of theta, from which you can calculate the coefficient of kinetic friction. You can see the theta value for kinetic friction is less than the theta value for static friction. Theta value for kinetic friction is less than the theta value for static friction. So the coefficient of kinetic friction will be less than the coefficient of static friction. That is the conclusion which we are arriving at. You just do it. You can do it as an activity, so that you can understand what is angle of repose and how will you determine the value of coefficient of static friction, coefficient of kinetic friction, etc.